everybody. This is Kenneth Wong, Senior Editor for DE 24/7, reporting from 3D Experience World in Houston, Texas. This is a conference with deep roots in the SOLIDWORKS community and the DIY or do-it-yourself community, also Makers community. This year, I met some members of the WALL-E Build Club, dedicated to faithfully recreating the WALL-E robot from the Pixar animation film.
Yes, SOLIDWORKS was used to do all the internal mechanisms for WALL-E. Well, the thing with WALL-E is that he can look you right in the eyes, and I come from building more like Star Wars droids, like R2-D2. And if you think about R2-D2, he's generally kind of kicked back and staring off into space. So when kids come up, R2's sort of like pointing his eye at the ceiling, and WALL-E, you can really just make eye contact, and people just melt when they see him. And it's made it the whole. It was about a 5-year build, and it made the time worth it. Absolutely, just to watch people's reaction. It's awesome. And then these actually are twist sticks, so that's what twists the head. So there's one. They each do that, and they're set to 50% weight. So you can twist one of them, and he'll move slowly, or you can do them both, and he'll go fast. So if you need to look at something quickly, you can do them both together, and he'll kind of snap his head around. And there's buttons on the top. This does his eyebrows, and then this one does the eyes. And then you can switch him to driving mode, and that keeps the head on this stick. But now this one doesn't do the head anymore. Now this one drives. And the twist still works with the that.
So we have a linear actuator driving a cam arm, and when I push the actuator down and up, you can see how the neck raises and lowers. So that gives a lot of life to the character, showing emotion, either excited or shy, what we saw in the movie. Some of the other aspects you saw there moving was some of the head movement. So we have it so we can pitch his head forward and back. We can roll it left and right, just like that. And then we can move the eyes independently up and down. So a lot of emotion you can gain from that. Some of the added attributes are his eyebrows. So we can use them to kind of give quick emotion. And also his eyes come in and out, so his irises look like they're focusing like a camera. So with all that combined, we can get some really dynamic movement and show the emotion. We use a control system that was designed by one of our builders in our community. It allows users like myself who are not so savvy with software to use just web applications to drive movements, simply by using sliders to determine your max position. At that point, it's really defined by our transmitter, which we have here, to drive the motion. So as a user, I can take each input and really play around with the mixing, because what I love is I can do one movement and it does 3 at the same time. So that compound movement allows us to animate WALL-E in a much fluid way that portrays the character without having it be cumbersome on the user or the operator.
In the keynote talk, SOLIDWORKS CEO Manish Kumar introduced 3 new AI-powered companions dubbed Aura, Leo, and Marie. There are signs that such AI-driven companions or copilots are becoming a standard feature of the design and simulation software packages.
So Infinite Form is an generative engineering platform which helps designers to design optimal parts for manufacturability and performance in early design stage. So in Infinite Form we also implemented Infinite Form AI Copilot, and major goal of this Copilot is to be in the interface between user and requirements and the software. Basically, Copilot can understand engineering requirements. If you have set of load cases which you can upload into the Copilot, which will understand and set up load cases, material properties, even library of tools and the specific machine shop, and final design will be adjusted towards this set of tools. So really, Copilot's there to be the layer between engineer and the engine that we develop. Another important role for the Copilot, once design is generated, copilot will analyze result if stresses don't exceed specific values, and will recommend on best way to improve the design, either to add material, to replace material, to reformulate the problem, and also to allow exploration of other manufacturing constraints. We can support the additive, CNC machining, extrusion, die casting, and also we work on injection molding constraints as well. Yeah, so this part actually was designed using Infiniform software, which was designed specifically for CNC machining, and it's an automotive part where the requirements were to carry a specific set of loads and to be manufacturable on the most cost-effective way. So engineers defined material properties as aluminum, defined set of load cases, and safety factor was supposed to be below 2, and this part should be manufacturable using CNC machining. And as you can see, part was designed fully automatically using Infiniform. The biggest advantage that the designs which are exported by Infiniform are fully parametric CAD. We have a plugin for SolidWorks where users can push initial models into Infiniform, optimize them, and then pull back result back into SolidWorks, including the entire feature tree. So you can get all the sketches, fully constrained sketches back. So we're closing loop here. The entire process takes minutes. So it's shortening design cycles from weeks to really tens of minutes.
Now, for those exploring reverse engineering, the first step is to digitize something that exists in the real world. 3D scanners play an important role in this workflow.
Sure, so this is our Leo, our flagship 3D scanner. It's completely wireless, has a built-in display, battery and processor, and it's basically a device for capturing 3D models that you can reverse engineer and inspect. So the Spider 2 is like a wired version of a similar sort of scanning device. The difference is that it's higher accuracy and higher resolution, uses the blue light technology, so it captures finer details, things like holes and ridges on the surfaces of objects. So let's say you were reverse engineering a part. What you could do is scan the object, you would get a 3D point cloud. That point cloud is turned into a 3D mesh in Artex Studio, our in-house software. You can tidy up that 3D mesh inside the software with our built-in reverse engineering and inspection tools. If you want to perform more advanced tasks in CATIA or SolidWorks or any other design software, you can export this 3D mesh either as a PLY, OBJ, STEP. We support a lot of the common file types, and we actually have direct integration with many of these softwares, right? So we have partnerships with, so we have Geomagic for SolidWorks that we sell. We have partnerships with Geomagic, so we have DesignX, ControlX that we market. We also have PolyWorks and ControlX on the inspection side of things as well.
Many SolidWorks users at the show rely on workstations powered by the latest generation of GPUs and CPUs. I met some users and hardware makers on the show floor to listen to their stories.
Yeah, for us, for us, we do all the design in SolidWorks, which not only allows us to develop the mechanical designs, but for us, it's the assembly process as well. So designing the individual components and then mating them together and seeing how the assemblies come together. Our products generally are quite complex. So our rear shock absorber has over 150 individual components. Our front fork has over 180 individual components. So having a really robust software is great. We also use the Dell workstations, CAD workstations with NVIDIA graphics cards. Gives us a lot of horsepower because again, when we start looking at these larger assemblies, you really need the power to be able to run SolidWorks efficiently, and that's what we use.
So we're showing our Dell ProMax 18 Plus. That's an 18-inch screen. It's our largest, most scalable workstation. This workstation here has 128 gigabytes of RAM and has an RTX Pro 4000 card in it. We're showing SolidWorks. We're actually showing a model from a reference customer of ours, Push Industries, who's a luxury mountain bike suspension manufacturer, and they use SolidWorks not just for their design, they use it for visualization, for marketing. They also use it for simulation and their camming software. So a real product developed on Dell machines inside of SolidWorks, and we're showing both the rear suspension here and the front fork. The front fork we're actually showing in SolidWorks Visualize. So this is using on this large T2 tower, not our most scalable workstation, but the best workstation for SolidWorks performance. And this has a single RTX Pro 6000 GPU, so an extremely powerful GPU. So you can run Visualize here interactively and get really, really high quality. Even if you were to navigate around this file, it would quickly render and denoise into a really highly visually accurate representation of that real product. And this isn't some separate model that's just for visualization. This is a model that is already being used for production and design and camming. They can, with the right hardware, click the right buttons and get a really high quality marketing visual to go with it. So these are the right size pieces of equipment for SolidWorks specifically. It gets bigger than that. We have multiple GPU systems, our Dell Precision 7960, 5860. These are platforms that can support multiple GPUs if you're doing simulation or visualization or reality capture, any of the things outside of SolidWorks users where you're trying to drive more value out of your 3D processes. So, but for SolidWorks users, the Dell ProMax 18 Plus and the Dell ProMax T2 Tower, and the T2 Tower with the RTX Pro 6000 card in it.
So what we're showing here today is Dell's GB10. The GB10 is our system on a chip, and what the GB10 is, it's a small chip but super powerful. So we have our Grace, our NVIDIA Grace CPU, along with our NVIDIA Blackwell GPU, together on one chip. And the beauty about this is that the Grace CPU can do its CPU work, the Blackwell GPU can do its GPU work, but they share memory together. So we have a coherent unified memory on that chip of 128 gigabytes. The beauty on this system here is that we're able to use that 128 gigabytes to do all sorts of different things within the realm of AI development. One of the things that I'm showing here today is some AI development inference within a factory and a manufacturing setting. We have a couple different examples here. One of them that I'm working with right now is actually worker safety. So what we have is a video here, security type of footage, camera footage of worker safety. What we can do with this video search and summarization demo is have a combination of different models working locally off of our GB10 here that it's able to infer and allow us to query this. And we're able to do this because we're using a vision language model, a large language model, and a retrieval augmented generation model as well. So that we're actually able to take data from video and be able to find whatever type of information we want to have. In this example that I'm running here, we're looking at worker safety in a factory setting or a warehouse setting. In this case, I have a bunch of clips that have studied the video, and I can actually chat and inquire with the data that it is inferred. One of the questions I'm asking here is the worker wearing safety gear? Is the worker wearing the PPE that is required for the job to make sure they're following code, safety regulations? And we're able to see here that yes, he's wearing his yellow hard hat and high visibility vest, which is excellent. We could also set this up to prompt us with alerts so that we have alert reasoning, the ability for it, instead of just relying on querying here, we could have alerts prompt us to say, you know, there is a worker not wearing their hard hat as an example, or their safety vest, or both. Another example we have here is this manufacturing workflow. We have a conveyor belt system that we're monitoring how packages or items are coming down this conveyor belt, and we're monitoring, you know, perhaps we want to look for differences in size of those packages or items on that conveyor belt. Are any of them damaged, right? So it's able to detect things like wrinkles in the package or tears in the package or dents or damage to the boxes. And again, we can query with that, or we could have it alert us that some of the packages are damaged, and we can very quickly zone in on how that damage happened as an example as well. So we have a bunch of different examples here on all of this running locally live right off of our GB10. The last thing I wanted to point out with this scenario is that users can actually download this same demo for free off of our build.nvidia.com site, specifically on our Spark section. We have a bunch of playbooks that we have there available for developers to try and learn from. You can even customize those a little bit. So it's a great resource for learning all about what the GB10 can provide for AI development.
Yeah, so today at Dassault 3D Experience World, we're launching our new Granite Rapids-based workstations called Intel Xeon 600 processors for workstations. We're super excited to talk about the benefits of both simulation work and visualization work. Here we have a demo in SOLIDWORKS Visualize, and it's using CPU-based ray tracing to do a lot of iteration work. So hey, I need to change the hood of the design here on the car, on the truck, and we're just showing the benefits of multi-CPU or large core count CPUs for that as well. Yeah, so this is using SOLIDWORKS Visualize, and here we are showing, hey, you can do CPU-based ray tracing, and when you're doing ray tracing, especially CPU-based ray tracing, it's going to be a noisy kind of image there that's coming out. And so we have our open image denoise library there to take that ray traced image and get a nice smooth image here. And so actually we've enabled it with our new AMX instructions that's built into every CPU core to really accelerate that denoising process with our new FP16 data type acceleration within AMX, within Granite Rapids workstation there. And so you can see as we move the image around, all of the cores start to light up. So we have our Xeon 696X processor. I believe that's our 64 core processor here. We also go up to an 86 core processor as well that we're also announced as part of our big launch here. So what's really great for Granite Rapids workstation, it can be used for CAD work, but it's also really great for finite element analysis, computational fluid dynamics. It's really that workhorse that can do the entire workflow pipeline for engineers, not just like CAD CAM and like SOLIDWORKS, but you can also do simulation work, visualization work like we're showing here, but also even like reality capture work, all within the same kind of workstation there.
That's all for the special video report from DE247 dedicated to 3D Experience World. For now, I leave you with some photos from the show floor. For more engineering news, go to Digital Engineering 24/7. That's digitalengineering247.com. Until next time, I'm Kenneth Wong, Senior Editor for DE247.
Wow.